I will be teaching you a solid method on how to determine the empirical formula and molecular formula of a given problem. Let's start off with the empirical. An empirical formula, by definition, is the simplest whole ratio of atoms of each element within a compound. This is usually solved through a given percent composition for a compound and their respective elements. Now, let's say you are given this equation. A compound is composed of 52.14% of carbon, 13.13% hydrogen, and 34.73% oxygen by mass. What is the empirical formula? First thing to remember, percent composition equals grams. That's step one. So you want to form your equation or process or whatever like this. The next step is to convert to moles. That's step two. Step two is to convert to moles. You do that by multiplying the weights by 1 mole over the atomic mass in grams of the element. For carbon, it is 12.01 grams. For hydrogen, it is 1.008 grams. And for oxygen, it is 16 grams. So if you do that, the formed equation should now look like this. The units that are the same should also cancel each other out. The problem should now look like this and give you this. The next step is to divide these moles by the smallest mole of the three, which in this case is 2.171 moles of oxygen. Your process should now look like this. Now, you just have to solve for each of these elements. Carbon should equate to roughly 2, hydrogen 6, and oxygen is dividing itself, so 1. This isn't a lot to memorize, but I will create a 9-letter acronym which should look something like this. Each of the 3 steps has 3 letters, so keep that in mind. The acronym is Peter Kane got caught trying milk donuts by Starbucks. Remember that. Peter Kane got caught trying milk donuts by Starbucks. This just means step 1, percent composition grams. Step 2, convert to moles. Step 3, divide by smallest. This is just a very straightforward process of finding the empirical formula. Now, the second part of this problem asks us to solve for the molecular formula if the molar mass of the compound is 138.204 grams over moles. Solving for the molecular formula essentially means solving the quantity for each element in correlation to a given weight, which in this case, as I said, is 138.204 grams over moles. In order to do this, find the atomic weight of the empirical formula. Because there are 2 carbons, multiply 12.01 by 2. There are 6 hydrogens, so multiply 1.008 by 6, and just add the singular oxygen. This should equate to about 46.068 grams. Now, in order to find the molecular formula, form your process like this. The atomic weights and the quantity of each element should have the same ratio. So divide 138.204 by 46.068 to determine the atomic ratio. This should give you 3. Now, multiply each of the elements in the empirical formula by 3, which should give you the molecular formula, which is C6H18O3. You can double check by entering this all into a calculator, like so, and yeah, it gives you an atomic weight of 138.204 grams. So for this 2-part problem, let's review the process. In order to find the empirical formula, follow these 3 steps. Percent composition of mass represents grams. Convert the mass of each element to moles using stoichiometry. And lastly, divide the moles of each element by the smallest amount of the bunch within the compound. Those 3 steps, as I said earlier, can be remembered by the acronym Peter Kane got caught trying milk donuts by Starbucks. Percent composition, grams, convert to moles, and divide by smallest. And as for the molecular formula, determine the atomic weight of the empirical formula. You can do this by just looking at the atomic mass of the individual elements and multiplying them by their individual quantities. Divide the molecular weight by the empirical weight in order to get the molar ratio between the equations. Then multiply the quantity of each element within the empirical formula by said atomic ratio. That's just how you solve a empirical formula, molecular formula type problem. that's it. Hope that helped.